1/3 of the world is connected to the internet. The majority are not. If you think about the traditional model of distributing internet access, it starts with typically a base station. It's a tower that provides radio signals that propagate to people's devices. What that means is you have to secure land rights to install that tower. You have to have the tower itself with its equipment and so on and so forth. You also need to be able to connect a cable or some type of microwave signal back to a place where you can get the actual internet. And then finally, you need to be able to get power to that. So if we look at each one of those pieces, what we want to do is challenge all of those assumptions to change the way in which we can think about distributing the internet. We know that the world's population, as a population density, covers 5 orders of magnitude. And it turns out that for that span of population densities, you need different solutions. So at low population densities, we're really interested in satellite systems, perhaps even across continents, and with very, very high capacity such that everybody can get a really high quality internet connection. Now, to do that potentially requires really new innovations, both in terms of low Earth orbit satellite systems, as well as geosynchronous satellite systems. So what's challenging about low Earth orbit systems is that the satellites are constantly moving over the field of view of people. And so what that means is you have to have a steady stream of satellites moving by at all time, which is like a fascinating problem to kind of think about. But it also means that if you think about what's on the ground, you have to have a user terminal that is continually tracking and watching those satellites as they spin by and catching that information. And so there's a fabulous set of problems to work on to try to figure out how to make that all work and how to make all those satellites interconnect with each other to make sure that you have an internet backbone that's essentially flying through the air as these satellites are moving by you. So that works really well in low density environments. But the challenge with that is that the further you get away, the weaker the signal gets when it's projected back onto the Earth. So in suburban environments, you need a different solution. So we're looking at a new type of plane architecture that flies at roughly 20,000 meters, 20 kilometers, because that's the point where the winds are the lowest, it's above commercial airlines, it's even above the weather, and actually can stay in the air for months at a time. And these planes are solar powered, and they sit there and they just circle around, and they have the ability to just broadcast internet down, but significantly closer than a satellite does. So one thing that we're working on, which I think ties all of these solutions together, is lasers as a mechanism for communicating between devices. So whether it's a satellite network that's moving across the sky, imagine lasers connecting those satellites together. We actually, on our team, have some of the pioneers in this field of what's called free space optics for being able to distribute really amazingly high capacity data streams, similar to what you find over fiber optic networks, through the air and between platforms. And we're just at the beginning. We have some amazing people on the team, and there's some awesome problems to solve. And to me, this presents an opportunity to be able to do something that you love, that you're passionate about, and that you really deeply know can have dramatic impact on people's lives. And we're looking for some fantastic people in aerodynamics, physics, communication systems to really help us solve this problem together.